So today we're going to be talking about cloud native at the farm edge. You can credit that bad joke to me, thank you. It's an interesting topic for me because we're going to be talking about Kubernetes, AI, tractors, we're going to be talking about immutable systems. I find it very exciting. If you like it, it was because of me. If you didn't, it was because of Jordan. No, I'm just kidding. Okay, why don't you get started, Jordan?
Sure. Thanks, Maro. Before diving into AI and Kubernetes on the edge and on tractors, I'm going to introduce a little bit what is precision farming and why do we do it. Starting with some statistics, basically it's estimated that about 25% of global crop production, and that's a moderate estimate, is affected by post-harvest losses. And the reasons are usually spoilage, labor shortage, or size and shape irregularities of the fruits. Now, to give you some context, in the Netherlands, the average farm is producing about 10 million fruits per year. That's usually apples and pears. And if you think about it, 2.5 million either don't make it to the market at competitive prices, or don't make it to the market at all, and most of it ends up in waste. At Aurea Imaging, we're trying to make a more sustainable orchard for the farmer, for the environment, and to reduce this waste. And how do we do it? We use common techniques used by agronomists. There are quite some techniques there, but a common one, and it's part of our core application, is called blossom thinning or precision thinning. How it works, you basically spray your orchards with a salty solution early on in the blossom season, and that causes some of the flowers to dry out. And then the tree uses its energy to the remaining flowers, causing less fruits to grow, but larger in size, more uniform in size, and often of better quality. In terms of our application, this is how it looks like. First, the tractor is driving in the field. We are doing computer vision in real time. We are detecting blossoms on the trees. We create a blossom map, basically a map showing the flower level of every tree. And we give that to the grower. Then the grower validates this map, adjusts some thresholds, and loads it to their sprayer implement. And then they drive again with their sprayer, spraying in an automatic way. And that basically increases their yield at the end of the year, increases the profit, and also they reduce the amount of spraying chemical that they use because we treat every tree independently. Now, enough about precision agriculture, more about the product. Our product is called the Tree Scout. It's an embedded device. It's basically a set of camera sensors. It's a ruggedized NVIDIA Jetson board, integrated with some peripherals, integrated with a tractor GPS for geolocating trees and blossom on the field, and also with a universal terminal that goes inside the tractor cabin for operating the Tree Scout. The application, if I run the video, basically you can see the application running when the tractor is driving in the field. That's a lot of data. It's a large amount of data. We use 15 frames per second. Resolution is 1080p, so about 25 megabytes of raw image data. And that has to happen in a short amount of time. It's crucial that the spraying happens during blossom season, before the flowers dry out. And apart from that, we also are limited with bandwidth. Tractors don't come with Wi-Fi on board yet, so we use 4G and LTE networks. So large amount of data, short time span, and limited bandwidth basically calls for an application that does most of the heavy lifting on the edge, before sending more lightweight data to the cloud. And that's why we use GPU-enabled devices like the Jetson to do all the AI inference on the edge. We run machine learning models on the edge, and then we send more lightweight data to the cloud. And of course, AI on the edge is quite a new domain, quite a niche topic, which is the topic of this presentation as well. And we're going to talk more about it. At this point, I'll introduce myself. I'm Jordan, originally from Greece, living in Amsterdam, and working for Aurea Imaging as a software engineer. I mostly focus on IoT data, our edge software, but also lately I've been quite involved into bringing immutable, containerized OS to the Tree Scout, which I'll give the floor to Maro to talk more about that.
Thanks, Jordan. My name is Maro Morales. I'm a staff engineer at Spectro Cloud. Spectro Cloud is doing different management of clusters of Kubernetes on the cloud, on edge, on-prem, basically solving the complexity that you might have there. I'm also a maintainer at the Kairos project. It's a CNCF sandbox project. And we do basically lifecycle management of systems through image-based Linux distributions that can be Ubuntu, OpenSUSE, all the major ones. And we also have now our own Linux distribution called Hadron, which is a very minimal upstream-focused Linux distribution. And last but not least, I also host the Cloud Native Belgium or Cloud Native Brussels group from the CNCF community. So if anyone is interested to talk there, also please contact me. You have my information there. Actually, the talk is going to be at the upper level, we could say, so we're not going to dive deep into technical aspects, but afterwards we will probably leave some time for questions. You can make, obviously, technical questions, or again, you just contact me later on. Running at the edge. Can I see some raised hands? How many people are running systems at the edge at the moment? Okay, I cannot see much because of the lights, but I saw a few hands going up. I don't know, I saw maybe like 50 people or so. I'm sure if we would sit down and try to come up with a definition of what the edge is, we would come up with 51 definitions of what the edge is, right? So that's also part of the problem. There's no one solution that fits all. Here I am putting some issues that you might have at the edge. You might encounter one, or you might encounter all of them at once. And the problem is that the edge can look like you're running in a tractor, like Aurea Imaging is doing it, but it can also mean you have maybe a grocery store and you have thousands of locations across the globe. It can mean so many things. It can be small devices, or it can even be a cluster of edge-specific machines, right? And so let's just address one or two of these ones here. One of them is maintenance, right? Like you might not want, or it might be too expensive to send an engineer to all of these locations, or maybe it's in a very, very remote location where sending someone would be dangerous or extremely expensive, right? Another thing is sometimes you have to make do with what you have at the edge. So maybe there is no technical person that can help you set up the machine. You want to make some sort of UI that is easy for anyone that can at least boot the machine and make one or two selections in a boot menu, for example. And a big one, of course, is security. If you're exposing your devices out there, like I was saying, in a grocery store, for example, it's the likelihood of that device being hacked, physically attacked, all of a sudden grows exponentially. Like, it doesn't mean that everyone is going to be an attacker, but it means that all of those people could be an attacker, right? And you might not want to get to that point. So that's why we came up with Kairos. Kairos is a system that can run, it's Linux at the end of the day, so it can run pretty much everywhere where Linux runs, on cloud, on-prem, on edge. But the difference is that many of the features that we designed on Kairos start on the drawing board thinking of the edge problems that they can solve. Because if you need it, well, you use it on the cloud as well or on-prem, but you cannot do it the other way around, right? So it has to be secure for the edge, and then if you need it, well, you also use it on your data centers. So that's exactly some of the topics. The first one, like I was addressing, is security. What do we offer, for example, in that sense? The first one is called Trusted Boot. Trusted Boot is a mix of using secure boot, which many people might already be familiar with, but on top of that, we use systemd in order to be able to measure and attest that the kernel, the init ramfs, and the kernel command line are the same ones that you signed and allowed to run in your system. If for some reason there's a change there, the system will simply not boot. It will brick itself, which might be a very good situation for you because, I don't know, maybe the device might be expensive, but more important than that, maybe the data that you have there is intellectual property or it's user data, if you're talking about data from related to governments or something like that, it might be too risky to expose it, right? So that's one of the cases that we try to address. Another one is no configuration drift. So if you have any kind of way of provisioning that does in-place upgrades, in-place changes, well, yeah, of course, the changes can be for good when it is running the way you design it to be, but the fact that a system can change for the good, it also automatically means that it can change for the bad. So for that scenario, we have certain part of the system that it is immutable, which means that, for example, if you try to do an apt install, it will simply tell you, I'm sorry, but I can't because I cannot write on the disk. There's, of course, areas where you can write because otherwise the system would be completely unusable. You have your user data or places where you can write logs, for example. And last but not least, another aspect that Kairos has is to try to do simple maintenance. Like I was saying, you might not have the ability to send an engineer to every location, so you want to have options in which maybe just from a booting menu, you can reset the machine or you can completely wipe, like factory reset the machine, right? And to this regard, we also integrated pretty well with Kubernetes because we offer a solution, Kairos Operator, that allows you from Kubernetes define how you want to do the upgrades of the nodes, and from Kubernetes, the full machine is going to reboot and start with the new version of the OS that you want installed there. And important here is to say that then you have also possibility to do canary upgrades to decide how many nodes you want to be rolling at a time, for example. And I think that is all I have to say for that.
Yeah, and actually Kubernetes was the feature of Kairos that stood out for us, and we decided to go for it. To give you a bit of historical background on that, when I joined Aurea Imaging 3 years ago, software architecture on the edge was completely different than what it is now. It was a single Python application running inside a Docker container. We were using Python's multiprocessing library. We were having a watchdog process, but basically the tree scout is connected to the tractor's battery. So we don't really have graceful shutdowns. The engine can turn off at any point, and we have hard power cuts. So processes can fail. The watchdog also fails. We cannot really watch what's happening. And that's where we thought, yeah, we don't really have control over our application. We didn't have control over the state of our app, no orchestration at all. So we thought we have to change course, and we only had 1 year until the next blossom season, so we needed a functional product within that time. We thought of the traditional approach, that is basically embedded ROS, robot operating system, with C++. It also comes with Python nowadays, but the team didn't really have the expertise for these embedded applications. It would be quite a steep learning curve. We estimated that would need more than a year, 1.5 years probably, to make it happen. So we were thinking of, hey, maybe we have to introduce a new container, message broker container, but then we also had to manage this container, and that's where Kubernetes came into the game. Coincidentally, I think it was 3 years ago at KubeCon, one colleague ran into Spectro Cloud, and they told us about K3S, which was quite a new project back then. So we thought, yeah, let's give it a try. We completely refactored our code. We split our code base into actual microservices, deployed our single node cluster with K3S on the Jetson, and we actually had a proof of concept within 3 or 4 months. We were surprised how easy it was to make something simple for the beginning, but then we added all the layers that we needed. And honestly, it plays quite well until today. It's the third blossom season that we are running with this setup, as we speak actually. And we have control, we can actually troubleshoot. We can identify the root cause of the issue, and we can easily deploy a bug fix into the cluster, into our application. But of course, we're not pioneers in K3S. I think there are other use cases as well.
Indeed. So of course, you might want to be reassured whether other people are also running these kind of setups. I'm not going to go into detail, but you can scan those QR codes and you can see 2 different talks in KubeCon. One with General Electric Healthcare and how they are running a system with Palette from Spectro Cloud. Underneath is using Kairos. And the other one is Dentsply Sirona. They ship dental devices all over the world. Both of them, I think, are very interesting. And the funny thing is that was the talk specifically that the guys from Aurea joined, and how the whole conversation started. So who knows, maybe this is the talk that starts the conversation. Just come and, like I said, please reach out. Indeed. So if you're interested, please have a look at those.
Yeah, in the end, we did end up adopting Kairos into the Tree Scout as the main operating system, and that brought quite some benefits for the company, for our operations mostly. Last year, this time of the year, we had about 25 devices deployed mostly in Europe. This year we have about 60, also some in the US, so our fleet is growing quite fast. So a homogeneous fleet was key into what we are doing, basically. We are heavily dependent on the NVIDIA stack, the NVIDIA ecosystem, as we use Jetsons. And this is a rapidly growing ecosystem that if you want to keep up to date with the industry standards, you always have to upgrade stuff that live in your host, like CUDA, the GPU interface of NVIDIA, NVIDIA Jetson, NVIDIA Jetpack, things like that. But also we had the need for upgrade our firmware on the host, for example, for cameras or some NVIDIA patches, or for third-party hardware, for modems. And it could also be that we want to upgrade to update a network setting. All these things don't live on the application level, but on the host. And Kairos provided the sophisticated way to do this over-the-air upgrades on a system level. How did we benefit from that? Basically, we don't have to send field engineers, as Maro mentioned. We don't have to send people in the field to do the actual upgrade. We don't have to send someone with a laptop and a cable to flash devices. We just do it once from our office, basically, and then we're done. We use over-the-air upgrades for anything host-related. In terms of operation, it was also quite useful that now we have everything defined in a Docker file. Our whole OS structure is defined there, so we know what to expect from our fleet. We can write reliable troubleshooting guides for our operations, and then we don't really need to involve engineers for this kind of support when something goes wrong. We have very standard steps into solving problems because we know exactly the package versions, the installer versions that are deployed across our field. And even if someone would try by mistake to install something, they wouldn't be able because the system is read-only. So yeah, easier operations. Also in terms of provisioning, we have to provision our devices from our office location before sending it to a customer. And with Kairos, basically we have everything defined in the OS image. We can actually send this OS image to our board supplier, and they do the flashing for us. And then the only thing we have to do is provide device-specific certificates or resources names, which is quite minimal, and then we have the device ready. So this really shortened our provisioning time to make a device customer ready. But also for our customers, for the growers, it seems that they have benefited from this transition. We are aiming for a 20% reduction in crop waste, and even though that's quite difficult to measure, especially since we are operating for less than 3 years with paying customers, it seems that the Tree Scout and the product is widely adopted, mostly here in the Netherlands and Northwestern Europe, but is being spread out. And all this wouldn't have been possible without us trying daring technologies like K3S, Kairos, and reaching out to the open source community.
Awesome. You cannot imagine how exciting it is for someone, a maintainer working on a technical project, to know that people are actually using it and using it for interesting topics like this one. There's nothing sadder than having a cool solution, but nobody adopts it, right? So this is, for me, the first big win. It's very good to hear that Kairos works so well for Aurea Imaging. But on top of that, we have these 3 different areas where the relationship between CNCF project and a company benefited also the open source project. The first one is that, as you can imagine, being an open source project, we don't really have the resources to go buying those fancy devices that they are sending to their customers. And the fact that they can do all the testing for us means that they can give us feedback, we can do changes into our core project and make their life easier. I don't know the exact numbers, but let's imagine something like if their original Docker file was something like 150 lines, it was reduced to something like 30 lines just because a lot of those parts were moved into one component we call Kairos Init, which is in charge of transforming that image into a Kairos image. And that also means that whoever comes now with, I think it's the Aurea NX that you guys are using. So now anyone new that starts, that wants to try Kairos on an Aurea NX, well, they have all those benefits, right? Like they can have this one-liner that converts their images. The second one is feedback on using Kairos. Overall, when you're in an open source project, one of the hardest parts is to hear how things are going. I mean, when they're not going well, people generally do approach you, but when they are going well, it's very hard to hear from them. And in this case, having a good relationship with them has really benefited because we understand, obviously, where we need to make changes, but also where it's actually useful for them, where it's clear, and which parts we should continue doing as an open source project. And last but not least, it has improved our collaboration mechanism. What do I mean with this? As an open source project, you have a certain type of governance, right? Like some people are maintainers, other people are contributors, etc., etc. But just having the project open is not enough. We want to have records of everything. If someone starts coming as a collaborator, we want to be able to put it out there, that it comes to a voting mechanism. And I'm more than happy to say that part of this collaboration, part of William Research joining as a maintainer has forced us into, okay, we need to do this now so that we can properly invite people to become contributors, so that we can give them also their recognition because of all the work that they are doing. At the end of the day, they are part of the community, and everything is open, everything is can be attested, right, that everyone can see it, the full community can see it.
And here you can see a demo of the end result. Basically, after we collected the data, we processed the data, we made a Blossom map. This map was loaded to the sprayer implement, the grower, and yeah, basically this is the end result, saving fruits, reducing waste, and reducing spraying chemicals. Thank you, and we are curious for your questions.